Hello and welcome to this Medic Mind tutorial where today we're going to be covering again abstract reasoning, and in particular this time looking at abstract reasoning triggers. So the lesson objectives of today is to introduce you to using triggers. In other words, what are triggers? We're also going to be looking at common abstract reasoning triggers that crop up in the UCAT, and finally we're going to be giving you a summary of everything we've talked about to help you remember these things going into the exam. So first of all, what are abstract reasoning triggers? Triggers are things that help you spot the pattern quicker. You'll see in the previous tutorial we used our algorithm SPONKS, and that's a really useful framework in case you ever get stuck. However, in reality, it's simply too long to go through each letter of that acronym in turn for every single pattern that you're going to see in the UCAT. You need almost a way of shortcutting a quicker method. That's abstract reasoning triggers, and triggers are essentially things that help you to shortcut to the pattern quicker. They're things about the nature of the pattern that you might see when you take a step back or when you look a bit more in detail at a particular feature. As you practice more and more, you will get used to seeing these triggers and it will become more and more second nature to you. So don't feel too overwhelmed in this session right now. It's just to introduce you to the concept of abstract reasoning triggers. So let's try an example. Pause the video now and have a go at this example using your SPONKS algorithm. Okay, going through it together then, the trigger here is the arrows. Whenever you see arrows in a pattern, you should always consider their orientation. What are they pointing at? Are they pointing up, down, left or right, or are they pointing at a particular shape? Arrows are so frequently used in the UCAT and they're always about orientation if they're present in every single example of the set. So looking at the arrows here, you can see that they either point upwards or downwards. Also looking at the shapes present in each box, you can see a repeated circle shape. That should be a really key indication that this is also potentially something to do with shape patterns. Looking a bit closer, we can see that in set A, focusing in on those circles, you can see that the circles are all white if they are present, whereas in set B, the circles are all black. That's a really important differentiator, and remember that, because this one is quite complicated with a lot of sub-patterns going on. Looking more at the arrows then, it's clear that they point upwards if the circle is present, and downwards if the circle is not present. If you can't exactly see in a pattern whether it's obvious whether the arrow is pointing up or down or the reason for it, try and relate it to other shapes in that example. Often the orientation of the arrow will be dictated by a property of another shape. Looking a bit more closely then, we can see that that orientation with the arrow up and down is the same across set A and set B. That tells us that it's not the differentiating pattern, indeed the colour of the circle is the differentiating pattern, but this extra pattern is important to recognise to help you maximise the amount of marks that you get. If you move on at this point and answer the questions, you're most likely going to get 60 to 80% of them right. However, in this particular example, there's also a secondary pattern, and this can be the bane of people's lives when they're taking UCAT. My general rule for secondary patterns is if you've spent a long time on a question and you've only just got the primary pattern, use the primary pattern and move on. If you spot the primary pattern very, very quickly, why not do an extra little check for a secondary pattern? You've got time and it might help you pick up an extra couple of marks. Also, if the primary pattern is so basic, it's likely that there will be a secondary pattern because simply everyone would get that mark. It's not a differentiator otherwise between candidates. So, just to recap, we've got the colour of the circles being the differentiator. We've got the orientation of the arrow being a common feature of both sets, something important to note. And the final secondary pattern here is all about the shading of the arrow. And again, whenever you see black and white shapes, you should start to consider colour at the back of your mind. And colour is always a good one to check if you're looking for a secondary pattern. In this case, the shading of the arrow is quite complicated. So in set A, it's black if there's a quadrilateral. And in set B, it's black if there's a triangle present. Okay, so we've got three potential patterns with this question. If we work through our SPONKS algorithm, that could take quite long. But instead we used the trigger, we saw arrows and therefore we considered orientation. We saw circles being present and therefore we considered shape. And finally we saw colours being present and therefore we considered colour. We shortcut straight to those items to help improve the efficiency of our performance. Okay, let's go through this pattern together then. So you can see in test shape 1, we can take it one by one each pattern that's present. So the circle is black. that suggests that we're looking at set B. That's the differentiating pattern. The arrow is pointing upwards and there is a circle, so that's a good sign. However, the arrow is shaded black when there's no triangle present. Therefore, this belongs to neither set. Test shape number 2, there's a white circle present. We're looking at set A. The arrow is pointing upwards in keeping with that circle being present, and there's no quadrilateral, therefore the arrow is white. That allows us to safely put it into set A. Looking at test shape 3, there's a white circle present. We're looking at set A. The arrow is pointing downwards. Oops, that's already wrong. The arrow should be pointing upwards if there is a circle present. So this belongs to neither. Test shape number 4, there's a circle present. It's black. We're looking at set B. The arrow is pointing upwards. That's a good sign because arrows should point upwards when there's a circle. And finally, there's a triangle, which means that the arrow is shaded black. That fits all the criteria for us to put it into set B. And the final shape, you can work this one out for yourself, but again, there's no circle present. Therefore, we would expect the arrow to point downwards. At this stage, it could belong to either set. There is a triangle present. The arrow is shaded black. Therefore, this belongs to set B. Okay, going through our Sponx algorithm for this one again might take a bit of time, so pause the video now and see whether you can zoom straight to the relevant pattern here by looking for triggers, looking for sort of gut feelings in the sets. Pause the video now and have a go. Okay, so no points for guessing that this is all about size. You can see instantly from the look of your eye there's a big shape and there's smaller shapes. It doesn't have to necessarily be 2 shapes present in a box. You can see in the top left of set A, there's a total of 3 shapes. Therefore, this is not really about number, it's more about size and also color, because you can see that big shape in set A is black, whereas in set B, the big shape is white, and vice versa for the small shapes. So taking this one by one then, we can throw up the answers now. So test shape number 1 belongs to set A. The big shape is black, and that's the criteria for set A. Test shape number 2 belongs to set B. The big shape is white. 3 belongs to A. The big shape is black. Now that one you could argue that there's differences between size, but actually the triangle is bigger, frankly. So that belongs to set A. 4 belongs to set A. Remember I said there's no real sort of pattern with the number here, so you can have as many as you like, as long as the big shape's black and the smaller ones are white. And finally, test shape 5 belongs to neither. You have to have at least one extra shape there to put that into context. So in this case, you've got the big black shape, but you haven't got any white shapes present. So therefore, we can't really categorize it into set A. And let's do this final example together. So pause the video now and have a go for this one. Okay, in this example, it's all about the level of intersections or overlaps. Whenever you see overlapping shapes, there are 3 things you should consider. You should consider the nature of the overlaps, either the number or the shape that's formed within them. You should consider the number of intersections, and you should also consider the number of regions created. Okay? So in this example, you can take a step back and see that set A involves a lot of these overlaps. Set B, they seem to be more distinct. That's important to investigate because it can be a useful trigger for you to start thinking about these overlapping regions. In set A, you can see that actually the first point of call would be count the intersections. You can see that in the top right, the middle left, and the middle right. And that would be a perfectly valid thing to do. In this example, I would potentially be more likely to consider the regions, given that in the top left, for example, there's no intersections. So if we start to count the regions, you can see that in the top left, we've got 3 regions. In the top right, we've again got 3 regions, including that overlapping area. In the middle left, we've got 3 regions. In the middle right, I think we've got about 5 regions. Bottom left, we've got again 5 regions. And then the bottom right, we've got 3 regions if you anticipate that sort of ring structure as a circle within a circle. So hopefully you can see that there's an odd number of regions in set A. In set B, that's simply the opposite. There's an even number of regions. So that's the differentiating pattern. But again, if you pick that up really quickly because you're hot on your triggers and you know what you're looking for, it's always worth considering a secondary pattern. And what's our favorite secondary pattern? Well, it's a color pattern. And in this case, it might be worth considering, in the event of an overlap, whether the shading makes any sort of difference. And in this case, it does. You can see in set A, when there's an overlap, the overlapping region is shaded black if there's straight edged sides creating that overlapping region, and it's circled white, or shaded white, sorry, if there's curved sides which are creating that overlapping region. And you can see that in the bottom left. Curved sides create the region, therefore it's white, and in the middle left, middle right, and top right of set A, you can see straight sides creating that region, therefore it's coloured black. So that's our secondary pattern here. Again, don't worry if you didn't see that. Secondary patterns are simply a bonus, and they should be viewed as such. Your primary goal with the UCAT is to find that primary pattern. So going through it together then, test shape 1 belongs to set B. There's 2 regions. Test shape 2 belongs to neither. There's actually 3 regions there. However, the middle region is shaded black, when actually it should be white if we're considering that extra secondary rule where curved sides creating the region means that it's shaded white. Test shape number 3 belongs to set B, and indeed we can kind of see that in the bottom right of set B, it looks very similar. And whenever you see these similarities between the test shape and the set shape, don't take that as an indicator that you've absolutely got it right, but it's a good sign. Test shape 4 belongs to set A, there's 1 region there. And finally, test shape 5 belongs to set A. There's 3 regions there, it's an odd number of regions. There doesn't have to necessarily be any overlaps. If you look at the top left of set A, there's no overlaps there. And again, this is an example where there's similarities between the set and the test shape. It gives you a bit of confidence that you can categorize that safely into set A. So let's look at summarizing it then. The key triggers with shape are if you see any sort of curved sides or weird angles going on. In this example, you can see on the left in set A, it's all about the curves, whereas in set B, you've got all straight sides. Now this is a really obvious example, but sometimes the colour of the shape, for example, can compound this pattern so that maybe the black shapes are the ones with curved sides and the white shapes are the ones with straight sides. It's always worth considering if you see these curved edges, and particularly these crescent shapes are used quite often. Another important shape pattern that's a useful trigger to know is symmetry. And symmetry, the triggers for this are whenever it looks quite neat. So if you take a step back and you think, wow, this pattern looks kind of nice, it's all sort of orderly, it's neat, what you're probably picking up on is the fact that there is symmetry in the pattern. As a result, you should investigate what lines of symmetry there are, how many lines of symmetry, and whether there are any at all in the first place. So in this example, you can see in set A, there's a horizontal line of symmetry, whereas in set B, there's all vertical lines of symmetry. If we move on to P for position, we can look at the common triggers that are associated with position. So in this example, you can see that there's no real differentiators between the types of shape that are present. They're all fairly standard shapes, they're all white, it doesn't really make any sort of difference the size. As a result, you might want to consider the position because these are regimented, locked in to a 3x3 grid in each example. As a result, that makes it really easy for the examiner to test you on patterns where one shape might be above or next to another one, or maybe to the left or the right of the side of the screen. As a result, you should always investigate position whenever you see this regimented pattern going on. So in this example, set A, it's quite overwhelming because there's a lot of shapes, but if you zoom in and look at a particular example and look at the relationship between the positions of the shapes, you can see that in set A, there's always 2 circles next to each other. Now in set B, the inverse, it may be helpful to think, well, in that case, there's not going to be any circles next to each other. But actually, the way the UCAT works, there tends to be a complementary pattern. So in set B, it tends to be there's a different type of shape that's next to each other. In this case, squares. So you can see in set A, it's all about circles being next to each other. In set B, it's all about squares being next to each other. If we look at orientation, your 3 kind of major clues that a pattern might be about orientation are arrows. We saw that in the previous example. Triangles, and this is a particular type of triangle. The long isosceles kind of triangles can be used as arrows in their own right. And finally, clocks. Whenever you have clocks, there's clearly a limited number of patterns they can test with that. You might be looking at the position of the arrows, you might be looking at the orientation of the arrows, or you might be looking at the angles between the arrows. So clocks are always an important one to consider when you're thinking about orientation. Moving on to number then. This is the type of trigger that you're looking for in number. You're looking for regular shapes that kind of are easy to count. Remember, the examiner is all about trying to test your pattern recognition, not necessarily your counting ability. As a result, they're going to make it easy for you to count those up if they want you to count them up. So you can see in set A, you've got those 3 triangles in the top left corner. They're all the same. minus the colour of course, they're all the same sort of size, they're very standard, they're easy to count. Likewise with the middle right, you can see those 3 repeated quadrilaterals. Repeated shapes are easy to count and therefore should alert you to a number pattern. The same thing goes with number of sides. If you see a sort of standard shape, a pentagon, a square, a circle, a triangle, all of these shapes tend to be associated with number of side patterns. Whereas if you see a complicated shape with curved and straight sides within the same shape, actually it's ambiguous how many sides that actually has. As a result, you should potentially veer away from counting up those number of sides if there's any sort of doubt over what exactly counts as a side. The examiner is going to make it easy for you. So if we look at this pattern, set A is all about an odd number of shapes, and we saw this in the previous tutorial actually, and set B is all about an even number of shapes. In this particular example, there's also a secondary pattern in that set A has to be either grey or white shapes, and in set B, it has to be either black or white shapes. So there's an extra sort of colour component there as well. We might also want to consider with number, the number of intersections, for example. We saw that in the previous example when there was overlaps. When you're counting up intersections, work out whether they're odd or even, or whether there's anything in particular that defines where and when an intersection takes place. In this example here, you can see that they've helpfully labelled the intersections almost with a nice little circle. So another important number pattern is all about the number of intersections. So intersections should be a red flag whenever you see overlapping shapes or intersections being particularly labelled as they are in this example. All of the intersections here are labelled with a circle. That tells you in big red capital letters, count these intersections. Now, it's not all about counting the number of intersections, however. Other patterns that might be associated with intersections are things like what defines an intersection. Is there a particular place for an intersection? Is there a reason why these two shapes overlap and create these intersections? In this example here, it's not necessarily about the number of intersections, but it's more about what defines these intersections and what defines whether that colour is white or black. You can see in set A, the circles are white when there's an even number of lines going into them. Whereas in set B, the circles are white, again when there's an even number of lines going into them, but in this case you've also got shapes with a black circle where there's an odd number of lines going into them. As a result, this pattern is not per se about the number of intersections, but about the number of lines associated with that intersection. Now let's look at colour triggers. So colour triggers tend to be things like spotted or shaded shapes, in addition to the additional white and black shapes. So in this example, you can see there's spotted and striped shapes, therefore we should be considering colour. Now this one's quite complicated, and I can't go into all of the complex patterns that are going on here. Indeed, the more you look at it, the more you find with this particular pattern. Put simply though, if we're looking at the differentiating pattern, filter out only the black shapes. Let's look at set A, the black shapes there. There's 3 of them in each box, whereas in set B, there's 2 of them in each box. That's enough to be a differentiating pattern, and if you were fed up with the question, you spent quite a long time with it, you can happily move on, answer the questions, you're likely to get about 60 to 80% of those right. If we look at additional patterns though, you can see in set A, the first circle, if it's there, has a dotted pattern to it, and every additional circle has a white pattern to it. In set B, the opposite is true. If there's one circle there, it tends to be white, and any additional ones are dotted. Now the more you look at it, you can also see in set B that the dotted circles always occupy a higher position. So these are complex interplaying rules, and don't worry if you didn't pick up on all of them. In fact, maybe some of them aren't even important for the test shapes. Additionally, we can look at the extra shapes that are present. In set A, if there are extra shapes, it tends to be a white hexagon. In set B, if there are extra shapes, one of them will tend to be white, one of them tend to be striped hexagon. So there's additionally an additional rule about this extra shapes going on. If we look at size triggers, it does what it says on the tin. If there's a big shape there, it's always worth considering size. And not only if there's a big shape, but if there's an important discrepancy between the sizes of shapes present in a box. For example, here you can see in set A, there's a big difference between the big shape and the small shape, and there's also a colour difference there, really highlighting your attention to the fact that this is all about size. So So as we've gone through this tutorial, my top tip would be to begin to create your own patterns and triggers list, things that you've spotted in previous questions that you've done which alerted you to what kind of pattern that was. I spoke earlier about the number pattern, about how I picked up on the fact that there are sort of standardized shapes that are easy to count. That was something that I only got by doing practice questions and recognizing that pattern repeatedly coming up. So by all means, make your own patterns list and make your own triggers list to help you keep a track of what patterns you've seen before to help you with future patterns. So here are our take-home points for today. The first one was we understood what the key abstract reasoning triggers were. We also introduced you to being able to use those triggers to narrow down your SPONX algorithm. In other words, not going one by one through each letter of SPONX, but zooming straight to the relevant information. And that's ultimately what abstract reasoning is there to test. In the medical world, you're all about looking at differential diagnoses. If you went through every single differential diagnosis in the textbook, you'd be there all day. It's all about narrowing down pattern recognition, zooming straight to the relevant differentials that might be important. And finally, we begin to talk about looking at building your own pattern list and your own pattern and trigger list. And this will be really important for you going forward in our future tutorials as you see more and more patterns to help you keep a track of what you've seen before and what works well for you.